Hi everyone, this is Eunice Leong, or some students call me Pon Leong. So in this particular video, we are going to continue from the Newton's law of motion. So let's go into a quick recap. Okay, so in the previous lesson, we were actually talking about Newton's first law of motion, or the law of inertia, which is actually talking about if an object is at rest, it will remain at rest. If the object is moving, it will continue on moving with a constant velocity, means that the magnitude and the direction is constantly moving forward. All right, Newton's second law of motion actually states that if the object is accelerating, there is a net force that is actually causing it to continue accelerate, and this particular acceleration is directly proportionate to the net force acting on it and inversely proportionate to the mass should there is no other external force. Alright, so this two law is actually mainly talking about how an object behaves, alright, when there are forces acting on it. So the question is, what happens to the forces when two objects interact? Because Newton's first law of motion and second law of motion is talking one object alone when the force is acting on it. So what happens when two objects interact? So that is our video we're going to talk about today. So now in this particular introduction, I want all of you to try this out. Look around you, try to look for a corner of the table or a book, alright, and then press a finger against the corner of the table or the textbook, alright, observe what happens. So in order to show all of you, so that's what I'm going to do. I'm going to take my ruler, okay, and then I'm going to press lightly onto my finger, and you would see that there is a dent on my finger. So if I were to exert more force, if I press even harder onto the ruler, alright, and you would notice that the dent actually becomes even more obvious. Alright, so what actually happened? Okay, so when two objects interact, for example, our finger pressing onto the corner of the book or the table, alright, the finger exerts a force onto the book, and the book will exert an equal magnitude, alright, which means the value is the same, but opposite direction force back to the finger, which means the action force is actually the force the finger exerts onto the corner, and the reaction force is actually the force from the corner onto the finger. Okay, so that is actually what happens, and that is actually Newton's third law of motion. So the definition for Newton's third law of motion is, for every action force, there is an equal and opposite direction reaction force. Alright, or in BM version or the Malay language version, setiap daya tindakan terdapat satu daya tindak balas yang sama magnitude tetapi bertentangan arah. So what does this really mean? This actually means that every force is actually one member of a pair of interacting forces. Every single force actually exists in pair. So when we talk about one force, it's actually one member of the interacting pair. Alright, so two members of a pair of interaction forces act on two different objects. Example, the hand placing on the wall. Alright, so the interacting pair is the force that the hand exerts onto the wall, and the other interacting pair is the wall's force back onto the hand. So these two members of interaction pair are equal in magnitude but opposite in direction. Or in mathematical term, the force that A exerts on B is actually equals to the force B exerts on A but negative sign. This actually means that it is equal in magnitude but opposite direction. So, right, the force exert by the hand onto the wall is towards the right hand side, and then the wall will exert the same magnitude but opposite direction force from the wall onto the hand. So this particular two pair of forces are the interaction pair, and they actually obey Newton's third law of motion. Okay, so let's go to the next slide. Now observe the vase placed on the table. What forces is present? Why doesn't the vase float or accelerate down towards the earth? Can you think of it? Right, what forces is actually acting on the vase? So I'm going to look over here. Alright, so all object on Earth is actually submitted to Earth's gravity. So when it is actually submitted to Earth's gravity, it will have a force, which is the gravitational force. So this particular vase will have a gravitational force that is pulling it downwards, or sometimes it is also known as the weight. Okay, so this is the reason why the vase doesn't float, because there's gravitational force pulling it down. But why doesn't the force accelerate down towards the earth? Okay, this is because there is another corresponding force that is exerted by the table onto the vase. Alright, so this force by the table onto the vase is also known as the normal reaction force. Right, because the vase is actually in contact with the surface, so there is a normal reaction force. That is the reason why the vase doesn't accelerate down towards the earth. It's being held up by the normal reaction force. So in this particular case, you would see that Earth exerts a gravitational force Fg on any object on Earth. So the vase does not accelerate down towards Earth because it is being held up by the table. The table exerts an upward force onto the vase, which is also called the normal force. So this force prevents the vase from falling through the table. According to Newton's second law of motion, the vase has zero acceleration because it is at rest, it is not moving, there's no velocity, therefore there's no acceleration. So according to Newton's second law of motion, F net equals to ma. As there is no acceleration, this term becomes zero. The normal reaction force pointing upwards minus the gravitational force pointing downwards equals to 0. And when we move it to the other side, it becomes, this one is supposed to be gravitational force, Fg, equals to normal reaction force. So the normal force actually balances the gravitational force. Hence, the net force acting on the vase is 0. So this actually obeys Newton's third law of motion. Every single action force, there is an equal magnitude but opposite direction reaction force acting on the object. So that actually concludes the video for Newton's third law of motion. So I hope you actually understand this. So till the next video, if you actually liked what I'm doing, please remember to like my video, click on subscribe, and click on the notification button. So till the next video, bye everyone!